Hello everyone, this is a GreenIPCore noise resistant IP test setup environment. This is a FPGA, and this FPGA is placed on a FPGA board which has a clock generator, the DIP switches, the LCD, the 7-segment display, and the LEDs. Within the FPGA, we are having a config command generation block, and these are different IPs which are placed inside the FPGA. This is the DUT which is under test. This is a noise resistant DUT, and this is a normal DUT. Other components which are used inside the FPGA all are noise resistant, like this one, which is a noise resistant configuration generation block, which generate configurations on the APB interface or any other interface where the IPs can be connected on it and configured based on the commands which are selected from here. The command goes over here and translated to the bus system and delivered to these DUTs. We have a display controller, display generator, which is also a noise resistant block, which is actually generating the display based on the configuration which is selected over here, and selecting from different DIP switches as well depending on configuration. It is driving the LCD controller, which is also a noise resistant block, which is driving out the differentials on this LCD controller. Another is a 7-segment display, which is connected to 4 7-segment display units on the FPGA board, and this the outputs of display, which is actually sometimes goes in the backside in this LCD, can always keep displayed on these LEDs, like the number of interrupts we are using, or number of noise resistance errors or errors due to noise in the system, or number of noise actually counted by the noise counter block into these LED 7-segment displays. On the LEDs, we are snooping out some inputs and driving out over here. So all these blocks, other than the normal IP, are boarded with noise resistance, and so that they can sustain the noise. The problem with using this specific IP is that the standard testing methodology, where some kind of block which can snoop the data out and put it on the PC, those blocks are not noise resistant, and they are actually proprietary, so we cannot use those standard methodology over here to test it out. It is a custom methodology we have built for ourselves. Let's go to the next part of it, which is understanding the different pins we are using over here in this test environment. So here in this is a FPGA test block, where this block is connected to a FPGA which is driving this test block, where we are having the same DIP switches, the LEDs, the 7-segment display, and the LCD over here. On the LCD, we are displaying different inputs, like different outputs, like the test name, the different outputs of the noise resistant thing, the different output for the normal things, different internal snooped outputs, and the full scale result of the IPs for normal and the noise resistant thing. On the 7-segment over here, we are displaying like the interrupts which are generated by the normal IP, the interrupts which are generated by the noise resistant IP, and the errors count, or the noise resistant noise event counted by the noise monitoring blocks on these 7-segment display. On the DIP switches, this side we are actually giving the commands to the block to generate different commands to configure the IPs, and this side we are actually driving out some inputs, which is actually also used by the same command generator block. Thank you.